Here we go, folks. 9.6, example 4. It's the last one we got together. So let's check it out. Use the binomial distribution in example 3. Hey, look, I remade it, color-coded it, made it into a nice, pretty bar graph. Here you go. And what is most likely outcome? Well, the most likely outcome is our tallest graph, which is 2, and it's a little over 0.3. Now, if I go back, I can see that at 2, right here, was a 32.9% chance, but I don't have to see exactly what that is. Again, I'm just looking at the tallest one. I know I can look at the numbers themselves, or I can just look at the height of the bar graphs. In this case, it's a histogram, just so we're clear. I called it a bar, but it's a type of bar graph. It's specifically a histogram. Anyway, back to this. I know my tallest is 2, so that means what is the most likely outcome of the survey? That 2 people own an e-reader. That is the most likely outcome of this survey. So what is the probability that at most 2 people will have an e-reader? Well, at most is a key phrase. At most is the idea of less than or equal to, because you can't go over that, but you can be lower than, you can be equal to it, but you can't go over. It's like a ceiling. So it's like kiddie ride that's meant for actual young kids. You can be at most this height rather than at least this height. At most means if you're taller, you can't ride the ride. You're too big. All right, back to that. If I take the probability of nobody has an e-reader, and the probability of one person has an e-reader, and the probability of 2 people have an e-reader, that's the same thing as finding the probability of at most 2 people having an e-reader. And the probability that there were 0 people who owned an e-reader is 0.090. The probability that 1 owned it was 0.267. And the probability that 2 people owned an e-reader that were 16 and older is 0.329. When I add all of those up, I get about. Now remember, this actually should have appeared up here as well, because these are rounded off or cut off. That something happened because they aren't naturally 3 digits long. That's just where we put them, rounding or chopping. So when I add these 3 numbers together to get that 3-digit number, I get 0.686, which means there's a 68.6% chance that 2 or fewer, or at most 2 people own an e-reader, given the distribution.